Transactions form an important part of any API, and Mule APIs are no different. So what exactly are transactions? In layman terms, I can say it is a series of actions that ensure underlying persistence on which the action is performed remains consistent irrespective of failures. And how do we achieve this consistency during failures? It's by rolling back, or by implementing two-phase commits, or by implementing saga pattern. Like any other transaction, Mule transactions also honor the asset properties. So let's understand transactions in Mule. Here is the list of frequently used modules and their corresponding operations that support transaction. All operations of DB modules support transaction, whereas only 3 operations of the JMS module support transaction. In Mule 4, transaction can be initiated by 2 ways, either by using a try scope or a source that supports transaction. Now here is a Venn diagram that represents different transactional actions supported by the try scope, listener, and operation. So let's start with the always begin action. As the name suggests, always begin creates a new transaction every time a new Mule message is received, and it is applicable only for listener and try scope. Now let's move to indifferent. So indifferent does not treat any message as a transaction, and it is only available with the try scope, and indifferent is the default action for any try scope. Then begin or join. So as the name suggests, this action will begin a transaction if there is no existing transaction ongoing. If there is any existing transaction, it will try to join the transaction, and if not possible, it will create a new transaction. Not supported. This is applicable only for operations, that is the database insert, database update. So it's applicable only on operations, and not support, as it suggests, it executes the action outside any existing transaction. So even though there is a transaction, it won't be a part of the transaction, but instead execute outside the transaction. So it doesn't have a transactional behavior. Join if possible. This is the default action for any operation, and what it does is, if there is any existing transaction, it will join it, but if there isn't any, it will just execute it outside the transaction. Then we have the always join in operations. So always join always expects a transaction to be in progress when a message is received. If there is no transaction, an error occurs. Finally, we have the none action, which is only available as part of listener, and as the name suggests, it does not initiate any transaction. So by default, any listener, be it a JMS listener, it will have as none, which is the transaction action. So only always begin is the transactional action, which is available with more than one module, that is the try scope and the listener. So that's about transaction actions. Now let's understand the threading behavior under transactions. So I have the same diagram which I had used in the thread pools demo. The only difference over here is that I have enclosed all the operations under a try scope, which is transactional in nature. And we also have our usual thread pools: CPU light, intensive, blocking IO, shared Grizzly, and dedicated Grizzly. Remember, if you are using Mule 4.3, all of these 3 thread pools are merged into a single thread pool, that is the Uber thread pool. So this understanding is only for the versions below Mule 4.3. So suppose we receive an HTTP request on a listener. So it will be taken care by the shared Grizzly, and the handover from the listener to the actual Mule flow is done by a CPU light thread, and the Mule message comes to our flow. Now the thread of shared Grizzly goes back, and a new thread is picked up from the blocking IO, and the blocking IO itself will do the whole transaction, as opposed to the previous approach where there is a constant context switching between the threads. In case of transaction, only a blocking IO will do the task present in the transaction. The only thing that is done by other thread is the handover from the listener to the try scope. That is done by the CPU light. Then, since this is an HTTP request, the coming response will be handled by a dedicated Grizzly. So here this won't be handled by the blocking, but it will use a dedicated Grizzly, and then the response, when it is sent back, it is taken care by the CPU light from the HTTP listener. So this is about a try block which is having a transactional behavior. Now there could be other ways to implement transaction, as we saw in earlier slides. We can use a message source which supports transactions, and JMS listener is one such message source. So now let's move to the other slide. So I have a transactional listener, and if you observe, the whole transactional scope starts right from the message source. Instead of starting after the message source in the previous slide, it starts from the message source. And from the message source, listening to the queue, everything to execution of the flow is done by the blocking IO thread. The only thing which is done by other thread is the response that is received by the HTTP request, that is done by the dedicated Grizzly. Other than that, everything will be done by the blocking IO, and the final response, if any, it has to be sent, it will be done by the CPU light. So now let's move ahead to the transaction types. So there are basically two types of transaction. One is the local and the other one is global. Sometimes they call it as XA or extended architecture. In Mule, you'll usually find people saying it as XA transactions. So let's understand local transaction first. What are local transaction? As the name suggests, they are local to a single resource. It means that it spans across only a single resource. So if you have one database, it will take care of any tables that are present in that database. If it is two databases, the local transactions won't work. So there are conditions for the local transaction. It's like all operation must belong to the same module. For example, if you're using a JMS listener, it should have, the transaction should only have the operations belonging to the JMS module and not the other modules like the database module. And in case if it is a database module, it should have only database module. All connectors should use a single config ref. So the global configuration that we used for our database insert update, it should be same. The same thing should be referenced. There should be no two different config references. If they are, then they fall under the global transaction. So let's move on to the global transactions. As the name suggests, it's global, right? So it can span across multiple resources, and it's based on the two-phase commit algorithm. We'll understand that in detail in the next slides, but as of now, just understand that it is based on the two-phase commit algorithm, and it's valid only on supported resources. Now, what do I mean by this point? It is that the underlying resources, it could be your database, it could be your JMS broker, it should support XA transaction. If it does not, then you cannot use the extended architecture. So for that, in such cases, you need to implement a saga pattern. So now let's move to the other slide. So let's understand the XA transaction. So this gray part is a Mule application, and it will have a transaction manager whose job is to manage all the transactions. So it takes care of the resource manager. So the resource managers will report to the transaction manager. So in this scenario, I have taken two resource managers which will control two different databases. So I have an H2 database and the other one is HSQL database, two different database. So that calls out for an XA transaction because we have two resources. Now the two-phase commit, as the name suggests, it has two phases. So the first phase is to prepare. So whenever a transaction is started, the transaction manager calls the participating resource manager to prepare for the first phase. So what exactly is done in the prepare phase? So the transaction manager will send an order to both the resource managers and it asks them to start the prepare phase. So whatever action, it could be your insert query, it could be your update query, anything will be returned to some local persistence, that is a file in your Mule application, wherever it is deployed, whichever runtime, Mule runtime, it will create this tx log file. It will be inside some qtx folder, and that folder will have this tx log file, and all the data will be persisted to this local persistence. Both the resource manager are supposed to do this job in the prepare phase. Once they send a successful response to the transaction manager, when both of them send and transaction manager receives the successful response from all the participating resource manager. In this case it's two, but there could be many, so it should receive from all the participating resource managers. If that is the case, it will order a second phase, which is the commit phase, which means after the execution of the second phase, the data will be committed to both the databases and you will observe consistency of data across the different resources. Now this was a scenario without any hiccups. What if the resource manager 1 commits the data but the resource manager 2 fails to commit the data? It could be the Mule application crashed, or maybe the HSQL DB went down. It could be any reasons, right? There are many scenarios of failure possible at any given point of time. So how does Mule handles this? So basically Mule has something called as the Bitronix transaction manager, which usually manages all this transaction, and its job is to scavenge for the remaining transaction. For example, if there are any transaction logs remaining even after the commit command was given to all of them, the Bitronix runs a recovery thread, and the job of that recovery thread is to find if there is any data present in the tx log. So if there is any data present in the tx log, the Bitronix will ensure that particular data is being committed to the end resource. So that's the job of the Bitronix transaction manager. The recovery thread is being used to handle any such exceptions. So even if your Mule application restarts, it will obviously have that tx log backup, and it will finally you will get a consistent data across both the database. Now this is a scenario where both the underlying systems were supporting XA transactions, that is the drivers, right? We add drivers when we create any connection. So both the drivers were supporting the XA transactions. So what if the underlying resource does not support transaction? In such case, you will need to implement a saga pattern. So basically saga pattern comes from the world of microservices, wherein there is a compensative action for any failures. So if any failures occur, you have to compensate that failure with some other action, like maybe delete the data or update the data, something like that. So that has to be done, and that has to be done manually. So that calls out for a complex use case. Now let's understand transactions with the help of a demo. For the demo purpose, I have a database created. It is an H2 database server which has a table test having two columns, ID and name. I have already populated it with some values and I'm going to insert some values to it. So I've created a flow with an HTTP listener to receive requests, a try scope that starts a transaction. The transactional action is always begin. By default it is indifferent, so I've made it as always begin. And the transaction type is local. We'll first start with local, and local is by default. We do not have any XA, so we'll go with the local transaction. I have a database insert which just inserts the value to the database, and to simulate some error I am intentionally adding a null, concatenating a null value to a string, which will obviously give us error. So we'll see how the rollback happens and how all things work. I've also enabled debug level logging on the org.mule package, so we get to see what exactly is happening behind the scene, how threads are working and how the database queries are fired and all those stuff. So we are doing that, and there are a few loggers to it. So now I'll try to run this project and let's see how things work. I've started the project in the debug mode, and also the logs are having the debug enabled for org.mule package. So I've triggered the flow and it's stopped at the logger, but before that let's check the logs. And like I said, the handover was done by the CPU light thread pool, and then the blocking thread is doing all the job, right? So all the threads, all the job that is being done right now is from the blocking thread pool, and as of now it is on logger. So let's move ahead, and it goes to the database connector. Let's see what is the status of the DB. We just have like 5 records. Now let's move ahead. Okay, the DB call was successful, and we can see the insert query has been triggered. Now let's check the database once again. So okay, so as we can observe, it has applied a table level lock on the database, so we are not able to fire any queries. So now let's move ahead. Okay, and we have the transform message, and there is an error over here, so it will throw an exception. So we got the error. Now let's see if we are still able to access the database or not. No, it's still holding the lock. Now let's make a step ahead. Okay, now it has been captured by the try block. Let's go back to the database and check. So we can see the lock has been removed, and we still have 5 records, right? We do not see the 6th record, the name Ned, coming over here. So it didn't make the changes at all. Now let's move, and the flow completes with an error. So when an error occurred, it didn't modify the records in the database, and the database is as it is in a consistent state. But when we were trying to trigger a select query, it had applied a database table level lock, which is not good, right? If someone is wanting to access the database, he might not be able to access it. So we do not want to add a table level lock. So what we can do is we can go to the connector configuration, and inside the configuration, in transactions tab, by default it is the transaction isolation, which tells you which type of lock do you want to provide a lock on rows, lock on table, what kind of isolation you want. That can be provided over here. So we have the read committed, means unless the read is committed, do not show that record. Unless read uncommitted, even if it is uncommitted, you show the record. Repeatable read and serializable read. So you can choose any of this depending upon your use case. So not configured will use the default lock that the database suggests, and in this case it gave a table level lock. So if we make it as read committed, we might be able to see only the records that are committed, and in this case it won't apply the table level lock. So let's just change to this read committed and hit OK and save it, and let's see how does it behave. So it's getting redeployed. Now I've triggered the flow again. Now let's move to the other step. Let's see the insert query. Let's go back to the database and let's see if we are able to access it or not. We are able to access with 5 records. Once the database inserts, does it locks the table? Let's go back and check it again. It's still locking the table. Let's move ahead, and again it will fail, and the data should not be inserted, and the lock should be removed now. Yeah, the lock is removed. So even the read committed didn't allow us to remove the table level lock. So we should try some other level of isolation. So now let's change the isolation level to read uncommitted so that we can read any uncommitted changes. Let's click OK, save it so that it gets redeployed. So it's redeploying the application. So I've made the changes. I've made the transaction isolation to read uncommitted and redeployed the application, and I've triggered the flow. So it's now on the logger. Let's go back to the database table and see what all values we have. We still have 5 rows. Last record is with ID 8 and Stalin. Now let's move to the next step and execute insert. Now in the last 2 isolations we were not able to see any records, right? It was applying a table level isolation, but in this read uncommitted we are able to read the uncommitted changes. That is, the new ID 16 net is reflected over here, and we have 16 rows right now. Now again it's going to fail, so let's see if we are able to get the record back. So I've jumped to next step and the error occurs. Let's see what happens to the database. We still see the 6th row, right? Now let's move to the try block. Now let's go back and check it again. So the record is rolled back successfully. Now we only have 5 records, right? Because the error occurred and it rolled back, and the transaction completes with an error rolling back the last record. So we still have 5 rows. The 6th row has been deleted. So this was read uncommitted. It is also called as a dirty read because we read a value which was not yet committed, and that could result in error. So in this way you can try out the different transaction isolation level and set it as per your requirements. So this was about a local transaction. Now let's execute a successful scenario because we were executing all the failures. So let's just execute one successful scenario so that we make sure that it's working fine. I'll save it and redeploy the application. So I've redeployed the application and I've triggered the request. Let's move to the next step. So it's in the insert. Let's see the status of the database. We only have 5 records. Let's move ahead. Now there should be the 6th record inserted because we should be able to read uncommitted data. So we have the 6th record, right? And in this time it will commit the data also because there's no error happening. Perfect. There was no error. So I should see the data. Yeah. So the data is not deleted and I got a successful response as hello message. So this is how we can use local transaction, define the isolation levels desired and perform the transactions. You can also handle what you want to do in case of errors by adding inside the error handling. Now This was a pretty simple use case wherein we had only a single resource. Now let's use the extended architecture transaction or the global transactions. So for that, for same purpose, I have an HSQL database established. So I'll be using two databases. One is the H2 database and the other one is the HSQL database, and I'll enable XA transactions to see how does the XA transaction works. So I have a persons table, and that persons table has only a single value. So I'll try to insert values in the users in the test table of H2 database and the persons table of the HSQL database. So let's just shut down the runtime now and make some changes. Let's go to the development view, and I have already configured an HSQL DB insert. So let's just drag and drop it over here. Now the few changes that we need to do is, first we need to go to the try block and ensure that the transaction type is made to XA. That is the first step. Then you need to go to the database insert, go to the connector configuration, go to the transactions tab and enable the use XA transactions. Hit OK. Let's go back to the flow again, and we have the HSQL insert. We need to make the changes to this as well because it uses a different config, right? So now let's enable transaction. So it's already enabled. I have already enabled the transactions, and the transaction isolation I have not configured. So let's just hit OK and go back to the message flow. So we are pretty much ready with the requirements for the XA transaction. The only thing that we need to do is go to the global elements, and like I said, the Bitronix transaction manager does the task of managing the resource managers, right? So I've added a Bitronix transaction manager. To add, you need to click create and just enter Bitronix. You'll get it in component configuration. Just select it. Upon selecting, it has no configuration, you just need to add that. So it will, Mule will right away use this Bitronix transaction manager. So now we are pretty much ready with the XA transaction setup. All we have to do is start the application and trigger the flow. So I'll run the application, I'll debug the project so that we understand what's happening behind the scenes. So I've made the changes and deployed the flow, and I've also triggered the flow. But before that, I want you to observe the logs. The handover was done by the CPU light, and then we have a log as beginning transaction. It is beginning the transaction. Now it says binding new transaction with Mule runtime BTI internal transaction, and everything is being done by the blocking thread from the blocking thread pool. And observe that after a particular period of time, we can see that it is executing XA recover, right? And this is done by the Bitronix recovery thread. Like I said, in case of failure in the commit phase, it's the job of the Bitronix recovery thread to execute an XA recover, and it will check the TX log file. So it says that it found zero logs to recover, so it's not recovering, right? So it will check the TX log file and try to recover so that both the databases are in a consistent state. So now let's try to move ahead. It's stuck at logger. Let's insert the data into the database table. But before that, what I've done is I have deleted the last record, the 6th record, because if I again insert the same record, it will give me a primary key violation. So I've deleted the last record. Now I'll so let's check the database table if the value is inserted or not. We only see 5 records. Now let's move to the another step and check it again. I can see the new record added, So now we are inserting it in the second database, that is the HSQL database. But before that, let's again check the console, and we have the new value in H2 database. It's not yet committed, but we have the value. The second query has also been fired successfully, and it has moved to the transform message. So now let's check the HSQL database if we are able to see the value or not. So it's taking some time. So most probably the value is still not committed, so we should not be able to see that value. But let's just wait for this database to return the response. So for some reason the HSQL database manager was stuck unless I moved it from the transform message. Maybe it applied a table level lock because I didn't configure any isolation level. That might be the reason it got stuck. So I had to move it to transform message, and then the query got executed. So I could not see any new row being inserted. I have only one row in it. So, and the transaction has obviously failed because I was trying to append a null value to a string, so it has failed. Now let's go back to the H2 database and see what do we have. So we have only 5 rows as opposed to 6 rows which were seen previously, means before executing the HSQL database. So it has been rolled back, and we successfully have failed the transaction and performed the rollback activity. So we do not have any records inserted in either in the H2 database or the HSQL database. Everything seems to have worked perfectly. Now let's just remove this error and let's carry out a successful scenario. I'll save this so that the application gets redeployed. I have redeployed the application and triggered a request. Let's see how it works this time. I've moved to other step. Now let's move. The data was inserted to H2 database. Now let's go to the H2 database and check for the new record. Yeah, we do have the new record. Now let's move on to the HSQL database. So we have the HSQL database ready. Now let's move to the next. So the data has got inserted successfully, and this time the transform message would not give any error. Let's again try if we can see the record, or it still gets stuck. No, for some reason the HSQL database gets stuck. It doesn't return response unless I move it further. It won't work. It's still not working. Let's wait for it. So the transaction is almost successful. If I hit forward, okay, we got the response, and we have the record Jeremy inserted successfully because we didn't have any errors, right? So it got successfully inserted and the flow ends. So now let's see again. From the test table, we have the new record Ned inserted and the new record Jeremy inserted in the HSQL DB. So this is how you can use the XA transactions when there are different database or your transaction spans across multiple resources. So if you are using a JMS with a database, even in that case you need to have an XA transaction. It will not work with the local transaction. So if we observe that it's trying to recover the transactions from the transaction log, just in case if the Mule server gets crashed or your database or JMS connection is lost for such reasons, it goes to the tx file to check the log. Now let's see where this tx file is located. So to check the transaction log file, you can use this variable mule.home inside the logger, which will print the home location of your Mule if you are not aware where it is. And in that location, so in this sort it will print, and in that location you can navigate. So like in this case I'm navigating. So in the .mule folder I can see the project thread pools. This is the project, and inside this you can see object store qtx log, qxatx log, right? So this is the one which can hold the file, and as of now tx1 log, tx2 log, there's nothing, right? So depending upon how many connectors you have, that many resource managers, depending upon the number of resource manager, you'll have this log, and all of them are empty right now because we didn't have any transaction which got failed, like system crash or anything. If there is, then it will have some kind of junk value which probably we won't be able to understand, and when the system is back on track, the Bitronix recovery thread will try to read the values from this tx log. So this is using this method, just place this mule.home in your logs, and you will be able to figure out where exactly is that transaction log file placed. So I hope you would have found this video useful and understood quite a few things about transaction. You should definitely try to play around the isolation levels that we had, and also try to figure out with different database. You can also try to add a JMS module into this and see how it behaves, so that you can understand in depth about the transactions in Mule. So thanks for watching.